Swayam Prabha. Digital India. Educated India.
In this lecture, I am going to talk about the kind of perspectives that are adopted or employed in STS studies to look at the science, technology, society interrelations. There are three perspectives. One is an internalist perspective, according to which science is independent of society. The divide between the world of science is opaque and rigid. That means the internalist world of science and external world of science do not interact, they are independent. The second perspective is society directs science in terms of what scientists should do, and this is called externalist account of science. And third perspective is science and society interact with each other. The divide is like a permeable membrane. There is a traffic between the two worlds, the internal world of science and the external world. Now let us focus on the first perspective, that is the internalist perspective or internalist account of science. As I said in the earlier lecture, that there are three major disciplines which contributed to the study of science and society interface. One is philosophy, the other is history, third one is sociology. The internal history of science postulates that history of science is a succession of ideas and facts. Science grows by replacement of old theories by new ones and discovery of new facts, linear fashion. The internal history of science emphasizes to individual scientists and their talents and their abilities to produce original and novel research. The task of historian then is to document the succession and the individual's talent who produced these ideas and contributed to the discovery of phenomena or invention of theories. And philosophers argue that in generating knowledge, nature, both rationalist and empiricist methods are used to generate logically valid and empirically verifiable knowledge. Philosophers argued that scientists produce knowledge by using inductive method and deductive method to understand the world. So the internalist philosophy argues that rationalist and positivist methods are used, and important in these methods are inductivism and hypothetico-deductive method. Both are ahistorical. They do not take into account the context in which the discoveries are made, the context in which inventions of theories are made. Positivism as a theory of knowledge. According to positivism, the natural phenomena are governed by laws, and the task of the scientist is to discover the laws by observing the world. Observations have primacy over theory. And inductivism is an example of empiricist theory of knowledge, according to which sense perceptions aided by our sense organs can generate valid knowledge about our surroundings. It is like saying seeing is believing, seeing things as they are. These are the acronyms, as it were, paraphrased sentences of empiricist theory. Inductivism works like this. A scientist makes singular observational statements, and these are verified in various contexts by repeated observations, and then you arrive at a general statement. Example, how do we know, or how do we say that all crows in the world are black in color? So this is a question according to which inductivist methods say we should make presuppositionless observations and objective observations. We should make as many observations in as many contexts as possible. We'll see that how many observations are required to make general statement is a problematic one. In some cases, a large number of observations may be inadequate, and in some cases, one observation is enough to make general statement. For example, a general statement about the impact of an atomic bomb. One observation enough to say what an atomic bomb can do. The problem with inductivism, as I said, is no matter how many observations, one cannot make a conclusive statement about the phenomenon. Example, crows. Unless one observes all the instances in the world, which is impossible. Hence, The inductivists resort to probabilistic statements about the phenomena, and probability ranges from 0 to 1. The closer one's observations are to 1, the more conclusive one's general statement becomes. Going back to the example of a crow, how do we say that all the crows in the world are black in color? The inductivists will demand that we make as many observations as possible, or observe as many crows as possible in different contexts. And the problem here is how many crows one should observe in order to make a conclusive statement. It is impossible to observe all the crows in the world because in terms of time, money, energy, it's going to be an enormous task. So we resort to probabilistic statements saying that I observed 10,000 crows in the world. All of them were black in color. So all the crows in the world probably are black in color. That is how the probabilistic statements are made. The other method I mentioned is rationalist method, which is also called deductive method. Deductive method is a method of generating knowledge based on reason or logic. A general statement, which can be a theory, which can be a bold conjecture, helps us to derive a hypothesis, or this has to be tested in actual reality. And this general statement has to be applied to observe a particular instance to find out whether the instance conforms to our general statement or not. Then we draw a conclusion. For example, all cows have 4 legs, and this particular animal is a cow. This particular animal has 4 legs, and hence this animal is a cow. So sometimes valid deductive logic may become empirically wrong. For example, a general statement which says all cows have 5 legs, and this particular animal is a cow, and so this cow has 5 legs, is a conclusion. Empirically, although it's a valid deductive logic, it's empirically wrong unless the cow has some genetic defects, right? So hypothetico-deductive method, which Karl Popper advocated in the logic of scientific discovery, according to him, the general statements like a theory or a bold conjecture helps us to derive a hypothesis, and we are going to make observations relating to this hypothesis. In that sense, the observations are theory-laden. Observational statements are made in the language of theory. It is through falsification rather than verification that our knowledge about phenomena grows. Hypothetico-deductive method involves the following steps. First, the bold conjecture or a general statement. You deduce a hypothesis from this conjecture or a theory. Operationalize the concepts used in the hypothesis. Test this hypothesis, and then if the results of the hypothesis support your hypothesis, results of the test, if they support your hypothesis, your hypothesis stands corroborated. If your hypothesis does not find support from the data or observations, it gets refuted. In this case, confirmation is tentative, whereas refutation is permanent. In the sense, there can be another instance where an observation may go against your theory or hypothesis. In that case, one has to revise the hypothesis. Karl Popper also says hypotheses have to be falsifiable. It should be precisely stated, testable, and it should be a categorical statement. For example, it may or may not rain on Wednesdays in a particular city, cannot be tested. It rains on Wednesdays in a particular city is a testable hypothesis. Falsification may be used to demarcate between science and non-science. Non-science may be meaningful but cannot be falsified. That which cannot be falsified cannot be admitted to the body of scientific knowledge. That's the argument of Karl Popper. And what are the problems with deductive or rationalist method? As I mentioned, even one instance is enough to refute a hypothesis or your general statement. This becomes a difficult proposition to accept because the context in which the observation was made has to be verified, has to be examined, whether the observations were made correctly, whether use of mission was involved, whether the mission was working normally, and so on. So that is a problem. In this case, even one observation is enough to overthrow your hypothesis or reject your hypothesis. Whereas in inductive method, we have seen no matter how many observations we make, we will not be able to make conclusive statement about the phenomenon. And philosophers have all made normative statements about what is scientific knowledge and how is it produced, and by examining the concepts, theories, and models in terms of logic and evidence. The turn of social studies of science in the 1970s, in the 1970s, social studies of science took a turn that focused on empirical studies of science, about which we'll discuss later. We'll see the critique of positivist rationalist philosophy of science. Thomas Kuhn, he was the one who recognized the social, cultural dimensions of internal world of science and the notion of a paradigm. He advocated science to be seen in its, he argued that science has to be seen in its historical integrity, and one cannot compare science of yesteryears with that of today. It has to be seen in its historical context in which it was produced. Paradigm is the central idea in Kuhn's work. Paradigm is an exemplar that has future potential as a frame of reference to look at the world. In terms of the interface with the external world, according to Kuhn, scientific community turns to the external world only in times of crisis. After acquiring a paradigm, scientific community insulates itself from the external world. Kuhn's work recognizes that science should be related to the context, that is time and space. Before we move on to the substantive work of Thomas Kuhn, we would like to mention that Thomas Kuhn's work opened up the idea of cultural factors influencing theory choice, the idea of a scientific community that shares a particular paradigm coming into existence, and the communication patterns among the subscriber to the paradigm becoming a very, very short and precise, because all of them know the fundamental statements of the paradigm. So, as I said, science should be seen, according to Thomas Kuhn, in its historical integrity. We have to relate science to the context and the work of practitioners at a particular point in time. According to Kuhn, one can see several stages in the emergence and growth of a particular paradigm. He recognizes that there is a pre-paradigmatic stage where the several groups would be making claims and counterclaims about a phenomena without coming to any consensus. For example, the light was seen before Newton as something which is a medium between the viewer and the object, and it is a kind of it is something that emanates from the object. Whereas Newton said that light should be seen, light consists of small corpuscles, and these corpuscles can be sort of seen, observed when they fall on a particular object. This becomes a paradigm because each corpuscle will have a mass, will have a certain kind of pressure that it exerts on the object it falls on, which can be measured. Now this becomes a paradigm. Newton was the first one to provide a paradigm of light, that it is in the form of corpuscles. The acquisition of a paradigm, for example, in the case of light, that light is corpuscles, opens up possibilities of future research which can throw light on the phenomenon of light in several ways. And once a paradigm is acquired, then it gives rise to normal science based on the paradigmatic theoretical beliefs about nature. And during normal science, what happens is scientists try to extend the paradigm to as many areas as possible. And during normal science, scientists also develop several standards of measurement, standards of observation, which are in line with the paradigm. And they also tend to work out several constants and work out several formulae. And all these things would only extend the paradigm. They do not raise fundamental questions about the paradigm. Normal science, according to Thomas Kuhn is like a puzzle solving activity. We know that although all of us who are trying to solve crossword puzzles, we know that a puzzle has a solution, and the solution has to be arrived at according to certain methods. And if you do this, you arrive at a solution. So the same thing happens in normal science, that you follow the methods, standard methods of observation, of experimentation about a particular phenomenon, about a particular question that you want to answer, and then you will get the answer either way. That is, normal science is a rule-based activity. The rules are provided by the paradigm. And as scientists extend the paradigm to various contexts, and scientists come across anomalies. Here we should know what an anomaly is. Anomaly is something that is against the backdrop of the received theory or received paradigm or received belief. So if something anomalous is seen by scientists, they would like to see what is that anomaly all about. First, they try to give a structure to the anomaly, and they try to investigate the anomaly and see if that can be made as something that is compatible, that can be made compatible with the paradigm. Or in some cases, anomalies are so profound that they cannot be accommodated within the paradigm, and hence there is a need for looking up for another paradigm. And these anomalies, profound anomalies, create a crisis in the scientific community or paradigm-based scientific community. They would like to investigate or propose several kind of candidate paradigms in crisis situations. Let me give an example how an anomaly can, a profound anomaly can give rise to a new paradigm. For example, in the oxygen theory of combustion was formulated in the 18th century. There are two people who were working on this problem. Lavoisier, a French chemist, found that whenever substances are burnt, there was a phlogiston theory according to which whenever substances are burnt, they lose weight. Lavoisier found that whenever a substance is burnt, it was gaining weight. He wanted to account for what is this substance that is adding weight to the substance that is being burnt. He said it's air in entirety. Simultaneously, J.B. Priestley in London, England, was also investigating the phenomenon, and he found that which is added to the burning substance is oxygen. Whenever substance is burnt, it becomes an oxide of the substance. So here, the anomaly is profound. Phlogiston theory said whenever we burnt a substance, something leaves the substance. That means it should weigh less after burning. But on the other hand, it was weighing more than what it was before burnt. Now, this anomaly could only be reconciled by changing the paradigm. It is called the oxygen theory of combustion. Whenever you burn substances, they absorb oxygen, become oxides, and that's how they gain weight. Now, this is how paradigms change paradigm change historically. During crisis period, scientists propose several candidate paradigms, and these candidate paradigms are evaluated. Sometimes scientists resort to thought experiments without knowing the goal of the experiment. Sometimes they conduct random experiments without knowing what will be the outcome. So this kind of a crisis situation, the scientists try to look for a candidate paradigm. One of the paradigms which is proposed by members of scientific community shows the promise of solving the anomaly that was so profound in the earlier paradigm, and also throws up opportunities for future research. And this candidate paradigm will be selected by the scientists for adoption and use in the research, for adoption as a perspective to look at the world and to do research. So this is how paradigms change, and as I said, whenever a paradigm is changed, what are the factors that go into the selection of a new paradigm. According to Thomas Kuhn, it is of course logic and evidence, but apart from that, there are some cultural elements which can also influence the theory choice. For example, notions like simplicity, notions like elegance, these are important criteria which makes scientists accept a new paradigm. In addition, there are certain religious beliefs which may also encourage scientists to adopt a new paradigm. For example, Kepler, who was the one who said that the planets around the sun move in orbits, he said any theory which placed sun in the center of the universe appealed to him, and so he subscribed to the heliocentric theory of universe. So one more thing we should keep in mind is that according to Kuhn, in pre-paradigmatic stage, several schools of thought provide speculative descriptions and explanations about natural phenomena. For example, light is described as a medium, or it is a property of the object on which light falls. For the first time, Newton conceptualized light in terms of corpuscles, as corpuscles. This opened up the possibility of looking at light as particles and led to the observations on mass of the particles, pressure they exert on the objects the light falls on, and the scope to measure such as mass, pressure and variations. In other words, conceptualization led to experiments. Acquisition of a paradigm marks the end of multiple speculative schools of thought. A particular paradigm is an exemplar that provides an agenda for future research. And let's also look at the components of research, which is very, very important. When people asked Thomas Kuhn to define paradigm, there are several, more than 20 ways in which paradigm was described by him. Some of the components of the paradigm are as follows. Let us see them. A paradigm consists of a set of theoretical statements and assumptions about the phenomena, novel methods and experimental techniques, standards of research, extension of paradigm to look at the world to make predictions on the basis of explanations provided by the paradigm, a metaphysical commitment to look at the world from the vantage point of view of the paradigm. And a set of, as I said, after acquiring paradigm, the period of normal science begins, and normal science is paradigm-based science, and normal science extends the paradigm to study as many phenomena as possible and as many contexts as possible. New techniques, new standards are evolved. Sometimes new constants are evolved, new formulae are evolved. Fundamental questions regarding the paradigm are not raised during normal science period. Communication among practitioners of the paradigm becomes very, very important. It becomes very short and precise. Whenever they publish papers, they do not recount the fundamental tenets of a particular paradigm. Emergence of a paradigm-based scientific community, which is a very important kind of a group that emerges. And as a fallout, new journals come into being which act as the platforms for reporting results of research based on the paradigm. It is a platform for communication. During normal science, production of scientific knowledge grows in a linear fashion in this sense. Normal science is like puzzle solving activity. The paradigm theory provides clues to solve the puzzle. For example, a crossword puzzle has an answer. In order to reach the solution, a person has to follow certain rules and procedures, and one arrives at the solution. Anomalies. An anomaly is an observation that is not anticipated by the paradigm theory. For example, where class attendance is compulsory for students, absence from class is an anomaly. Practitioners of the paradigm give a structure to the anomaly and try to investigate it. The practitioners attempt to make an anomaly as expected by making small changes to the paradigm theory. However, some anomalies are so profound and they resist solutions within the paradigm and make scientists to raise some fundamental questions about the paradigm. How does one solve these profound anomalies? Profound anomalies raise fundamental questions about the paradigm theory, thus creating conditions for a change in the paradigm. For example, the phlogiston theory of combustion conceptualized that whenever a substance is burned, something leaves the substance. It means that the substance experiences loss in its weight. However, scientists observed that whenever a substance is burnt, the substance gained weight. This is a profound anomaly according to the phlogiston theory. Anomaly against the backdrop of phlogiston theory. Two groups of scientists, Lavoisier in France and J.B. Priestley in Britain, began investigations in 1774. When Lavoisier concluded that the thing that was added to the burning substance was air in entirety, Priestley, however, concluded that the thing that contributed to the weight gain in the substance was oxygen. This observation created a paradigm of oxygen theory of combustion, and it displaced the theory of phlogiston. It means that whenever a substance is burnt, with the addition of oxygen, it becomes an oxide of the substance. For example, when iron is heated up, it becomes iron oxide. Crisis and response to crisis. According to Thomas Kuhn, crisis is a situation in which the paradigm is not able to anticipate new phenomena when the practitioners extend the paradigm to the newer areas. The practitioners look for insights from other disciplines and also outside world for ideas during the crisis period. And at other times, the scientific community based on paradigm insulates itself. They carry out experiments without any anticipation regarding results. Thought experiments are conducted by the practitioners. Several candidate paradigms are proposed. One of them gets accepted as it solved the anomalies of earlier paradigm and proposes a new agenda for research. Testing a paradigm. Testing paradigms involves simultaneous verification and involves simultaneous testing paradigms involves, as the paradigms are incommensurable, the practitioners have to subscribe to the new paradigm based beliefs about nature on the basis of future opportunities for research. The test involves what the new paradigm is able to solve the problem. Okay, the test involves what the new paradigm is able to solve that the earlier paradigms failed to solve by applying the earlier paradigmatic theory. Incommensurability of paradigms. Thomas Kuhn argues that the paradigms are incommensurable because the paradigms are worldviews. They describe the world not only differently, but they describe different worlds. For example, the geocentric theory of universe provides one kind of a worldview, and the heliocentric theory of universe provides another kind of a worldview. For example, according to the geocentric theory of the Earth is in the center of the universe and the sun revolves around the Earth. In the heliocentric theory of universe, the sun is in the center of the universe, our universe, and it is the Earth that revolves around the sun. These are incommensurable worldviews. According to Kuhn, the shifts in paradigms are revolutionary shifts because just now I mentioned that the two paradigms not only see the world differently, but they see different worlds. These incommensurable paradigms, whenever one paradigm changes another, there is no continuity, there is disruption, there is discontinuity. So in that sense, paradigmatic shifts occur in a revolutionary way, in a discontinuous manner. Once a paradigm is acquired, then there is a normal science period. In the normal science period, science grows in a linear fashion and it reaches a steady state after some time and then declines and then a crisis sets in, right? And it's at this point the scientists resort to, as I said, thought experiments, random experiments, and also try to propose several candidate paradigms. And one of the candidate paradigms gets accepted as a new paradigm because it, as I mentioned, solves some problems which the earlier paradigm could not solve. So, as opposed to the linear view of history of science, Thomas Kuhn proposed revolutionary shifts in science, discontinuous shifts in science, and this is a novel kind of a way of looking at history of science. He also compares scientific revolutions with political revolutions. Political revolutions are inaugurated when the existing institutions cannot solve the problems which are partly generated by the institutions. Hence, there is a need for a change in the institutional order. Some leaders look for an alternative institutional order or paradigm, institutional order that can address the problems. For example, Russian Revolution of 1917 changed the society from a capitalist one to socialist one. The foundation of capitalist society is still private property, and revolutionary shift from private ownership of property to state ownership or common ownership of property is a major shift in the institutional order, a revolutionary shift in the institutional order. In the case of paradigm, the change in the paradigm is necessitated by the fact that the paradigm can no longer predict novelties, and paradigm fails to solve anomalies which become anomalies against the paradigmatic beliefs. So these anomalies are partly a result of the paradigmatic beliefs about nature, because universe or nature is so very vast and paradigm is a human construct, and whenever you extend the paradigm to different areas of look at different aspects of nature or universe, you come across anomalies which are not anticipated by the paradigm. Kuhn's account, as I said, is an internalist account, in the sense that, as I mentioned, Kuhn always argued that the so-called internal world of science has its own dynamics. However, he also recognized that social cultural aspects within the internal world of science, and he argued that only at times of crisis the scientists would look at other disciplines or outside world for inspiration and new ideas. Following sociology, which is, as I said, another discipline which looked at science, it also looked at initially the internal world of science. In sociology, Karl Mannheim, who was the founder of sociology of knowledge, he argued that all knowledge except scientific knowledge is socially, culturally conditioned. Robert Merton, following his characterization of knowledge, Robert Merton observed that science should be seen as an institution and has its own ethos. Robert Merton is a sociologist who employed functionalist perspective to look at society and its institutions. And according to Merton, the goal of science is extension of certified knowledge, and this certification is done by criteria which are impersonal, and these criteria are technical criteria, and these are logic and evidence. And a sociologist, the technical criteria are beyond the scope of sociology, and what sociologists can do is to look at social moral norms that guide the conduct of scientists when they are engaged in doing science. I will, in the next lecture, we will see what is Mertonian paradigm and how it looks at science and as an institution. Right? Functionalism is a theory to study society, according to which the society is composed of institutions, and each of the institutions contributes to the maintenance of the system. Or science is an institution, the goal of which is the extension of certified knowledge. An institution is a set of norms, rules that govern the conduct of individuals who play given roles in the institution. Mertonian ethos of science, Merton pointed out that people who practice science must imbibe certain ethos of science, certain ethos, so that they can perform their roles as scientists. As I said, science as an institution has a set of ethos which every person involved in doing science must imbibe. The ethos of science are universalism, communism, disinterestedness, and organized skepticism. What is universalism? According to this ethos, certification of knowledge is based on evaluation of knowledge claims according to impersonal technical criteria, that is logic and evidence, by members of the scientific community without any reference to the claimant's social background in terms of race, class, and caste. The evaluation of knowledge claims does not depend on the social class or nationality and gender background of the person making the claims, as I just now mentioned. They are irrelevant. Communism means scientific knowledge is not owned by individuals, it is shared. Scientists bequeath their knowledge to the colleagues, and for posterity. At best, the scientist who makes original contributions would get recognition for the achievement. Disinterestedness. A scientist who advances new theory does not develop vested interest in the theory. He allows his peers to evaluate the theory in terms of logic and evidence, and if the theory stands the tests of the logic and evidence, it is admitted to the body of knowledge. Organized skepticism. This is a methodological principle according to which judgment has to be suspended until all relevant evidence is gathered. Merton added two more norms that have to be conformed to by the scientists in order to achieve the goal of the institution of science. One is originality. Every scientist must strive to produce original knowledge so that it can be added to the body of existing knowledge, thus extending the horizons of scientific knowledge. Scientists who conform to this norm will be rewarded in the form of recognition, and the recognition can take several forms, like for example, Nobel Prize is one of the recognitions which is the highest recognition, highest form of recognition for scientific achievement. In addition, there are several awards instituted by different countries for recognizing the work of scientists in their countries. Next norm he adds is humility. Practicing scientists should cultivate humility. Humility means that one should admit, I do not know. It enables one to learn new things and contribute to the knowledge. Merton also studied in the history of science. He found that there are disputes over priorities in science. It means people were trying to fight with each other in trying to argue who discovered a particular phenomenon first or who invented a theory first. This is linked to recognition. If a scientist is the first one to be recognized as a contributor, he will be rewarded. Some scientists entered into disputes over priority. Priority means who claims recognition first for the original contribution. Invention of calculus, there was a dispute between Leibniz and Newton in the history of science. Disputes over inventor of the theory of evolution. For example, Charles Wallace and Charles Darwin. Wallace withdrew his claim because Darwin collected evidence from different parts of the world, and so Wallace said the credit should go to Darwin. Merton points out that in the history of science, in the 17th and 18th centuries, persons engaged in inquiries into natural phenomena felt that their ideas would be stolen. Some of them did not make their ideas public. It is in this context that the Royal Society of London provided a platform to natural philosophers to share their findings. As a logical corollary, Royal Society started a journal, Philosophical Transactions of the Royal Society, so that the natural philosophers could publish their findings and also establish priority. This was the first journal that was established to enable scientists to communicate their ideas to the world and at the same time to stake their priority. This journal of the Philosophical Transactions of Royal Society was an invention that was made to document the publications of scientists. So why do these disputes arise? Okay, this is related to, we will see why do these disputes arise. Before that, we would like to say, since the establishment of the journal, the Philosophical Transactions of Royal Society, several journals have been started for each of the disciplines and each of the specialities in every discipline by the professional societies or some foundations, etc. Today we have journals published by professional societies, commercial publishing houses, and with the internet we have open access online journals today. While open access journals do publish fast, the question is as to what extent they have an open access and what are the conditions that the authors have to meet to publish their articles in the open access journals. How reliable is the peer review that it depends on in the open access journals. I said we will discuss why disputes arise over priorities. Merton questions as to why scientists get into disputes over priority. He says that it is not because of the vested interest or self-aggrandizement, but because of the norm of originality and the consequent recognition that the original contribution bestows on the author or a scientist. There are three responses from scientists in this regard. One, conformity. Those who conform to the norm of originality publish original contributions and get recognition. Second, deviance. Some scientists adopt deviant methods such as plagiarism, fudging data, and making fraudulent claims to get recognition. Ambivalence. Some may not show any interest in staking their claims for priority. Especially, I would like to spend some time on the question of deviance. Today, we have seen, periodically we see in newspapers that certain scientists, a certain scientist belonging to a particular institution has plagiarized from an earlier work and published the same work claiming that it is his own or her own. This is plagiarism. This constitutes ethical misconduct, and it also constitutes breach of integrity by the scientists. In history of science, there were several fraudulent claims also were made in order to get recognition. So that is why in today's context, most of the universities adopt this anti-plagiarism software to check all the publications that go from these universities or organizations to see whether or not they are original, whether or not they are plagiarized. The norm of institution decide on to what extent the similarity can exist between the articles where a student or a researcher borrows from other articles. This ranges from 10 to 15%. There can be a similarity between the research papers or the content of research papers to the extent of 10 to 15%, and above that is considered to be unacceptable, and it may constitute as plagiarism. I think with the advent of internet, it's easy to access information on literature in various fields, and students resort to internet sources for the literature, and sometimes they copy paste the literature without acknowledging the original author. Plagiarism means that you do not acknowledge the original author from whom you have borrowed. This, as I said, is professional misconduct which cannot be tolerated, which cannot contribute to the advancement of knowledge. And Merton also talks of institutionalized pattern of evaluation. He said, if the goal of science is to extend certified knowledge, who should certify this knowledge? As mentioned above, every scientist is motivated by the institutional norm of originality. If one makes original contributions, one gets recognition. It is for this reason that the scientists communicate their knowledge as quickly as possible to the journal so that he or she can preempt others, can stake the claim for priority. Who should certify that a particular claim is original or not, a particular paper is original or not? It is done by a group of peers who include the editor of the journal and the peers who are practicing science in that particular field. So there are these following actors who really are involved in certification of knowledge. One, editor of a journal, who is the gatekeeper. The editor may not editor may not be an expert on all fields of research that the journal wishes to communicate to the wider audience as part of the editorial policy. So the editor depends on experts or peers in the field of research to advise the editor whether or not a particular paper is worth publishing in the journal. The editor sends out the manuscripts that he or she receives from the authors to the expert reviewers for their judgment regarding the quality of contribution in terms of originality of approach and method. Then the reviewers, the peers, act as umpires who certify whether or not a research paper communicated by an author has an original element, and it's worth admitting to the body of knowledge. The criteria of evaluation are logic and evidence, and the kind of instrumentation that was used if it is experimental research, and the reliability of results. Authors who produce research and would like to communicate to the wider audience in the discipline or specialty so that they get recognition. The authors sustain the journal. However, they have to conform to the norm of originality of approach, method, or critique of earlier findings. Readers who go through the contributions in the journal get to know the latest developments in the field and build on them in their own research work. In other words, the editor, reviewers, authors, and readers constitute the group that is collectively involved in extending the knowledge. Mertonian functionalist approach maintains that all the members of the group conform to the norms of science or ethos of science, and no one deviates. However, in the real world, actors resort to deviant behavior to see that they get recognition. This amounts to failure or to maintain scientific integrity or ethical misconduct. I just now discussed why some people adopt deviant methods to get recognition. See, the group of people involved in certification of knowledge, that is the editor, the peer reviewers, and authors, are also not exempt from this deviant behavior or ethical misconduct in some cases. The editor may reject a paper even without sending the paper to the reviewers, as he or she has some professional or personal issues with the authors, as the editor knows the identity and institutional affiliation of the authors. The reviewers, as they have been selected by the editor on the basis of their expertise in the field, may resort to plagiarizing the ideas contained in the paper that they received for review to claim recognition and publishing them before the reviewer gives his opinion on the paper to the editor. The authors may compromise professional integrity by resorting to deviant behavior manifested in the form of plagiarism, as I mentioned, fudging data, and sometimes making fraudulent claims. There are several examples in the history of science regarding this. As I said, Merton deployed functionalist method or functionalist theoretical approach to study society and also science. And according to this functionalist approach, the conformity to norms will be rewarded and deviance from the norms will be punished. Applying the norm, we see that those who conform to the norm of originality are rewarded and those who deviate are punished. It is in this context the editor, on the basis of reviewers' comments, has to decide whether or not a research paper is an original contribution. If the reviewer points out that the research paper they reviewed has plagiarized, then the editor has to inform the head of the institution to which the contributing author is affiliated to initiate necessary disciplinary action for the misconduct. Merton also talks of inequalities in science. Merton, when he studied the publication patterns of scientists and funding patterns that scientists received, he found out that there are inequalities in science. Merton, in his empirical analysis of performance of scientists, found that a small number of scientists produce disproportionately more research papers. This small number of scientists get disproportionately more recognition compared to others, and they become elite among the scientific community in a given specialty or a discipline. They attract more funds and do more research, and they occupy positions in prestigious academic institutions. That means it is a question of rich becoming richer and the poor becoming poor. Merton draws this from Gospel of Matthew, where Matthew says that give unto them who already have, take away from them who do not have. It is make rich people richer and poor people poorer. And these elite scientists are the role models to emulate. They act as nucleus around whom a specialty develops. They direct the research in a field. Okay? If you look at pictorially the distribution of recognition and the number of scientists, you see that the number of scientists at the top is very small, and look at the recognition they have, enormous recognition by a small number of scientists, right? So this is the pattern of recognition that one sees in science even now. And Merton says that this Matthew effect can be seen at least in the following situations. One, in cases where original contributions are simultaneously made by two different groups, the group which has a reputed scientist will be recognized first. That means if two groups make simultaneously original contributions and they communicate to the world, the communication sent out by the group which has a reputed scientist will be recognized first, because they know that this reputed scientist is responsible for this kind of contribution. Second, when a research paper is communicated by a group that has reputed scientists, it is more likely to be accepted. When a scientist, when in a group, if there is a Nobel laureate who is also one of the authors of the paper, if that paper is communicated to the journal, it has a higher chance of being accepted without much problem. Third, contributions made by already recognized scientists would be read by more people. In the sense, today there is explosion of information, scientific information, explosion of journals and articles, and people tend to be very selective in who they want to read. If there is an article published by a Nobel laureate or a reputed scientist, they would read it first rather than reading other papers. Now, Merton contributed extensively this kind of empirical studies, which really helped us to understand the internal dynamics of science. And basically, Merton's work is again an internalist internalist account of science, where he only looks at the social moral norms and the extent of conformity by the scientists to these social moral norms, and he leaves out the technical aspects of science. That is, as I said, Merton says the technical aspects of knowledge would be evaluated by impersonal criteria of logic and evidence, and sociology does not have that kind of expertise to look into the content of science. Let's look at what are the problems with Merton's approach to sociology of science, or the critique of Merton's approach to sociology of science. Merton lists a set of norms, and he also recognizes that there are counter norms. This was also pointed out by Mitroff, who said there are a set of counter norms operate in the life of scientists when they practice science. The Mertonian norm of universalism has a counter norm of particularism. According to universalism, we just now mentioned, claims of knowledge are evaluated on the basis of technical criteria, not on the basis of the social background of the individuals who make some knowledge claims. But in reality, we find claims of knowledge may be accepted as they come from a reputed institution or an institution in an advanced country, and they may ignore contributions that are made by countries from less developed countries. Merton's norm of communism, according to which the knowledge produced by scientists is shared, it is not owned. That is, it is open. This knowledge that is produced is bequeathed to the peers and students by the scientists. That means there is no ownership of the knowledge. However, there is a counter norm to this communism, that is secrecy. Scientists maintain secrecy about the research. At certain stages of the research, they do not want to reveal to anybody else as to what they are doing, what kind of research problem they are working on, what are the results, and so on. They try to keep them secret. Again, other Mertonian norm of disinterestedness, for this norm there is a counter norm, vested interests. Scientists may develop vested interests in their theories or models and try to protect them, propagate them as far as possible. The other norm that Merton mentioned that scientists follow is organized skepticism. There is a counter norm to this, that is judgment. In some cases, empirical evidence may come much later for a theoretical claim. Whereas Merton said organized skepticism means you suspend all judgment till all the evidence is collected for a particular claim to be accepted. As I said, in history of science, in some cases empirical evidence may come much later for a theoretical claim, and such theoretical claims are really admitted to the body of knowledge. In reality, scientists employ or deploy norms and counter norms in different contexts and justify their actions. Just because some scientists maintain secrecy about his work, it cannot be construed as some kind of a deviance, but according to scientists, at a given stage, they have to maintain secrecy. Otherwise, somebody else may steal the results and publish much before they do that. So both the scientists deploy norms depending on the context, depending on the situation, and just justify their actions. The other aspects is, where, as mentioned, the inequalities in science according to Merton is because some scientists are more productive, some scientists are less productive. That is, more productive scientists will get more credit, more recognition, and also more funds for further research. But the question is whether or not the opportunity to do science is equitably distributed. For example, when we say some scientists are highly productive, we must see what are the conditions which make them more productive, right? This is an important question. Whether these conditions are equitably distributed for all others, or it's only concentrated in a few situations where a few scientists exploit this kind of opportunities. So that's why if you look at internationally, we see that most of the contributions come from advanced countries in the West, and of late from China, and of course India also. Once India was much more ahead of China some time back, but today our publications have come down compared to China. So that means these countries, in advanced countries, the opportunities to do science are more equitably distributed compared to many other countries in Asia, Africa, and Latin America. So it's very important that the opportunities to do science must be equitably distributed so that more people can contribute and contribute original work and get recognition and add to the body of knowledge. The idea of heroes in science, Mertonian paradigm in sociology of science, or Mertonian approach, tries to create heroes in science, in the sense that according to Merton, those scientists who are highly productive or talented, they are uniquely gifted, and that's why they are more productive. Now this is making heroes out of these individuals. Rather than see science as a collective or group activity, it is seen to depend on individual talents and unique talents. That is, certain individuals become dominant figures in a particular field of research, and they are the ones who direct research in that particular field. And this is what leads to what is called invisible colleges, where a small group of elite scientists in a particular research field direct the dynamics of research in that particular field. Whether or not this is whether or not this situation is good for advancement of knowledge, there are two sides to the coin. One says there must be some individuals who really are committed to a particular research field and take research forward in that field, and there are others who argue that these opportunities must be equitably distributed, especially to youngsters, so that they can also contribute to the advancement of knowledge. Thank you very much.